Hello, algebra students. Mr. Lawrence here, and this is the third video in scientific notation. This will talk about adding and subtracting. But before we do that, remember I've been comparing this to the stuff we've already done. Hey, can you add 3x to the fifth plus 2x to the fifth? You sure can. It would be what? 5x to the fifth, right? But can you add 6x to the 12th plus 2x to the 10th? Can't do it. They're not like terms, right? The variables and exponents have to match. Same thing for scientific notation. See problem number 1 here? I've got 3 and 25 hundredths times 10 to the 6th plus 1 and 11 hundredths times 10 to the 5th. These don't match. They're not like terms. Now with scientific notation, I can make them like terms, and when I do, then I can add. So let's make them like terms. Now I'm not going to change them both. I'm just going to change one of them. I could either change this one so that it has an exponent of 5, or I could change the second one so it has an exponent of 6. I'm going to change the exponent of 5 into a 6. So I'm going to multiply this by 10 to the first. That'll get me a 10 to the 6th, won't it? All right. But then I have to divide this part of the number by 10 to the first. Otherwise, I've changed the number, which moves that decimal point there. So my new problem actually becomes 3 and 25 hundredths times 10 to the 6th plus, and watch what I'm going to do here. I'm just going to write this vertically, boom, 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 times 10 to the 6th. All right? Hey, I need a little placeholder here because I notice I don't have a number lined up. I'm going to put a 0 in there. All right, now, I don't add these. These are just like the variables, right? So I'm just going to get a 10 to the 6th. This is how many 10 to the 6th I have, plus that many 10 to the 6th. So when I'm done, I'll just have 10 to the 6th. Don't make this too hard. So I'm going to add 1, 6, 3, and a 3 out front. So I'm going to have 3 and 361 thousandths times 10 to the 6th, and there you go. Pretty simple. You just got to make sure those exponents match. Let's take a look at number 2. Okay, I've got a negative 3 and a negative 1. I'm going to multiply this guy by 10 to the 2nd power because negative 3 plus 2 will be negative 1. Then I'm going to divide by 10 to the 2nd power, which will forcibly move this decimal point 2 places to the left. So I'm going to have 0.0624 times 10 to the negative 1st, and I'm adding the 2 and 24 hundredths to it, and if I like I can put some placeholders in there. That'll be times 10 to the negative 1st. So when I add them together, I'm going to have 10 to the negative 1st, right? Because I'm just counting how many I have. I'll have a 4, need my multiplication symbol, a 2, 6 and 4 is 10, carry the 1, a 3, my decimal point, and then there's a 2. There you go. Now you just have to be careful. If you add it and get an answer that's not in scientific notation, or if you subtract it, you'll have to convert it to scientific notation, just like we did with the multiplication and division. All right, so last one here, it's a subtraction problem. It's done the same way. I've got an 8 here and a 7 here, so I'm going to multiply this guy by 10 to the 1st, which means I'll divide this by 10 to the 1st, and I'll put that decimal point there. So we have 4 and 32 hundredths times 10 to the 8th, and this will be 26 hundredths times 10 to the 8th. I think I might even have called it an x to the 8th previously on mistake, but it's showing you that I even think of it like a variable. It behaves like a variable. It's not a variable. Okay, 10 to the 8th is a number. It's 1 followed by 8 zeros. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. And so it's 100 million. Okay, but it behaves like a variable when doing these kinds of problems. So I'm going to subtract, and let's see, I'm going to do a little borrow in there. 12 minus 6 is 6, 0, and 4. So 4 and 6 hundredths times 10 to the 8th, and there you go. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.